Okay, let's find the missing sides in similar triangles. After this lesson, you should be able to identify corresponding sides in similar triangles and use proportions to calculate the missing side length. Let's get started. All right, so here we have two similar triangles. How do I know they're similar? You ask. There is no similarity statement. That's wise of you to ask. But I know they're similar because I can see that they have corresponding angles that are congruent. So this right angle is congruent to this right angle. These two swoops and these two swoops mean that these two angles are congruent. And then the third angle also is congruent. So I know they're similar triangles and there's a missing side. I'm going to assign it a variable of y. So the missing side kind of looks like a G. Let's say it's G. So G is our missing side length. Okay. And I want to figure out what G is. And I'm going to use the fact that I know that the sides on similar triangles are proportional. So I know that the ratio of the sides are always going to equal the same number once they've been simplified, as long as they're corresponding sides. So I can see that side 15 corresponds to side 5. Does everybody see that? Side 15 here is a corresponding side to side 5 on the little guy, because that side goes between the same two congruent angles. The single swoop and the double swoop, the single swoop and the double swoop. Now, when I'm making my proportions, it's really important that I'm consistent. So I'm going to write big triangle over small triangle so that I stay consistent, and I always put the side lengths from the big triangle on the top and the corresponding side length from the little triangle on the bottom. So that's going to give me my scale factor. 15 over 5 is my scale factor for these similar triangles, and that's going to be equal to the ratio of all the other sides. Well, I'm going to pick the sides that have the unknown, the missing side. So here I've got this side. Ooh, that was messy. I've got this side right here. And that corresponds to this side right here because they're between the same two angles. So I can write another fraction, big triangle on the top. The big triangle, the side length is G. That's the side I don't know. Small triangle on the bottom. The side length is 4. I could make another one, which is 9 over 3, but that is not helpful. So that's just extra information that I don't need. All I need is one fraction where I know the numerator and the denominator, and one fraction where I have an unknown for either the numerator or the denominator. All right, from here, we need to solve for G. You could do that in a couple of different ways. Cross multiplying would work, or you could see that G is being divided by 4 and you need to multiply by 4. So I'm going to simplify this side. 15 divided by 5 is 3. And now you can see that all I need to do, G is being divided by 4. To solve for G, all I have to do is multiply by 4 on both sides. 4s will cancel, and I will get G is equal to 12. All right. So my missing side length is 12. Let's do another one. All right, this is from your book. It's on page 273 on your book. Now here, it's not so obvious what my corresponding sides are. So they're asking for the scale factor and to solve for x and y. To find the scale factor, I need two corresponding sides where they are both numbers. These triangles are twisted and turned. So I'm going to use my similarity statement to help me figure out what the corresponding sides are. So whenever you have a similarity statement, it is your best friend if you're trying to figure out corresponding sides. The letters are all in the order. So if I just use one letter, I can find the corresponding angle. So Angle T is corresponding, which means also congruent to angle C. Angle I is corresponding and congruent to angle A. And I know that these two angles are congruent because they're vertical angles, and vertical angles are always congruent. Okay, so that's going to help me. Now, I'm going to again decide that I'm going to put the numbers from the big triangle over the numbers from the small triangle. You have to be consistent there. I need a pair of corresponding sides that are both numbers, no variables in there, to get my scale factor. So let's see what we got. How about NC and IN? Are they corresponding sides? Well, if they were, they'd be in the same place in my similarity statement. NC, N and C are the first and last. IN are not the first and last. So these are not corresponding sides. NC is going to correspond to TN. How interesting is that? Who would have guessed? All right, so side NC is going to correspond to side TN. Don't go with your gut. Go with the similarity statement. And NC and TN both have numbers, so I can use them to find my scale factor. So I'm going to put the side length of the big triangle on the top, the corresponding side length from the little triangle on the bottom, and that's my scale factor, 15/8, which does not simplify, so that's what we've got to work with. Okay, now they want us to solve for x and y. Let's start by solving for x. So x is side TI. Oh, again, let's pick the line tool. Let's make it tidy. TI. I need to know what side corresponds to TI. So I'm going to use my similarity statement. TI are the first two letters in this description of the triangle. So their corresponding side is going to be the first two letters in this description of the triangle. So TI corresponds to CA. Did you know that? Would you have guessed that? Maybe. TI and CA are corresponding sides. So I'm going to take 9. So I'm going to take my 15/8. And I'm going to set it equal to the corresponding sides. Big triangle, 9, over little triangle, x. All right, so that's my equation. I need to solve for x. And for this one, I think cross multiplying. Because that x is in the denominator, I think cross multiplying is where I want to go. So I'm going to multiply on the diagonal, 8 times 9. And I'm going to multiply on the diagonal the other way, 15 times x. 8 times 9 is 72. 15 times x is 15x. Divide both sides by 15 to get x by itself. And we get x is equal to 72/15. Well, 72 is 2 times 2 times 2. That's the 8. Times 3 times 3. That's the 9. And 15 is 3 times 5. So I can cancel a 3. And I get 24/5. But since they have decimals for the side lengths in the problem, I'm going to go ahead and change that into a decimal. So 24 divided by 5 is 4.8. So x is equal to 4.8. So that answers one question. They also want to know what is y. So we need another set of corresponding sides. Y is side N. Oh dear, I keep forgetting to pick my line tool. Y is side NA. So I'm looking to the corresponding side to side NA. So NA or AN are the last two letters in this description. So they're going to be the last two letters in this one. So IN. And you probably knew that because it was the only side we hadn't chosen yet. So those are corresponding sides, NA and IN. So let's set up another proportion. I'm going to use 15/8 again because that gives me my scale factor. And then I'm going to make sure I put y on top because y is the side length from the big triangle. and 6.4 on the bottom because 6.4 is the side length of the small triangle. I can cross multiply here. Stick with the cross multiplying. So we're going to multiply on the diagonal on one side, and we're going to multiply on the diagonal on the other side. 15 times 6.4 is 96. Oops, let's do that in black. Is 96. And 8 times y is 8y. I'm going to divide both sides by 8, cancel the 8, and I get y is equal to 96 divided by 8 is 12. So y is equal to 12. So we found both of the missing sides on our pair of similar triangles, thanks to our similarity statement. Thanks, similarity statement. All right, let's try another one. Given that triangle ABC is similar to triangle DEF, determine the value of x and y. And again, this one's kind of confusing as to what our corresponding sides are. So I can fill in our corresponding angles. Angle A corresponds to angle D. Angle B corresponds to angle E because they're both in the middle, right? And angle C corresponds to angle F. That is kind of confusing. If you are confused by this, what I would recommend is that you redraw one of the triangles. So this is a tip. Redraw one of the triangles so it's oriented in exactly the same way as the other triangle, right? These are all twisted around. They do it to confuse you. You can thwart them by redrawing it so it's oriented in exactly the same way. So I put E up here because that matches the 2 swoops on angle B. I put F over here because it matches the 3 swoops on angle C, and I put A down here because A and D. Oh, whoops, there shouldn't be an A. See, that's why you check. Put a D down here because A and D are corresponding congruent angles. And then I have to fill in all the information that was on this triangle. So between D and F, that's an X. Between F and E, that's a Y. And between E and D, that's 18. So that was kind of a lot of work. But now that I've done it, I can totally ignore this other triangle. In fact, I have the ability to make it disappear. You don't, but I do. Look at this. Oh, you're gone. You're dead to me. So now I have these 2 triangles, and I'm not going to make as many mistakes because they're oriented in the same way. It's easier to see what my corresponding sides are. So I want to find x and y, and the first thing I need are a pair of corresponding sides that have the same, that both have numbers. So I'm going to pick side AB and side DE. In fact, that's the only one you could pick. It's the only one where both of the corresponding sides have numbers, and that's going to give me my scale factor. So my scale factor is 30 over 18. Yeah. Now to solve for one of the variables, I need another pair of corresponding sides. And I know that the ratio of this new pair of corresponding sides is going to be the same because in similar triangles, the ratios of all the corresponding sides are the same. And again, I'm doing big triangle over small. You got to be consistent. If you sometimes switch them up, it is not going to work. So let's try, I don't know, yellow. So let's do y first. So side y is FE. And the corresponding side on this one, I could check my similarity statement, but because I drew them in the same way, I know it's going to be CB. So FE and C, B are in the same place in the similarity statement. All right. So 30 over 18 is equal to big triangle, 35, over small triangle, y. There's my proportion. I can solve it by cross multiplying. 18 times 35, and set that equal to 30 times y, or 30y. So 18 times 35 is equal to 30y. 18 times 35 is 630. Yeah, I used a calculator. Of course I did. Divide both sides by 30. And we get y is equal to 21. Nice. Okay, let's find x. So that's going to be our last pair of corresponding sides. So CA corresponds to FB. So I'm going to create another proportion. I'm going to stick with 30. Oops, that's very thick. I'm going to stick with 30 over 18. That is my scale factor. I'm going to set that equal to 25, the side length in the large triangle, divided by x, its corresponding side length in the small triangle. And then I'm going to cross multiply. Oh, cross multiplying. How fun. So I'm going to multiply 30 times x, and I'm going to multiply 18 times 25. 30 times x is 30x. 18 times 25 is 450. Divide both sides by 30 to get x by itself. And x is going to be equal to 15. There we go. We found x and y. I think we've got one more. All right. And again, it is tricky. They drew the triangles right on top of each other. We know they're similar. We have a similarity statement that's telling us that they're similar, but it is going to be hard to create our ratios looking at it like this. So in this case, I would redraw not one of the triangles, but both of the triangles. So there's the big one, and there's the little one. I'm going to orient them in the same way so it's easy to tell what matches up with what. So the big triangle is TWV. The little triangle is TSU. Does side TV correspond to side TU? Well, I can just check. Side TU corresponds with side TV. So yeah, they're oriented in the right way. And now I can just copy this information onto these triangles. So the distance from T to V is 6. That's what this is saying. The distance from T to W is 8. And the distance from V to W is 10, right? For my little triangle, the distance from T to S is X. The distance from T to U is Y. And the distance from U to S is 5. So now I have two similar triangles oriented in the same way, not overlapping each other. I've copied over all my information. So this guy is dead to me. We are going to blot him out. Okay. I need to find the missing side lengths. Hopefully you're getting pretty good at this. Corresponding sides, let's get a pair. It looks like side VW and side US are my corresponding sides that are both numbers. And that's going to get me my scale factor. I'm going to stick with big triangle over small triangle. So I'm going to put 10 over 5. Now I want to set that equal to another pair of corresponding sides. Let's go with TS and TW. It's not great. You get the idea. Big triangle over small triangle. So I'm going to have 8 over x. Now I could simplify 10 over 5 to 2. It's just going to make my life easier, right? When I cross multiply, 2 times x is 2x, 8 times 1 is 8. Divide both sides by 2, and I get x is equal to 4. Yay! All right, let's do it again. Same scale factor, 10 over 5, which is 2. And now I'm going to use my last pair of corresponding sides. So we've got TV corresponds to TU, which means I can write the proportion 6 over y. Why is 6 on top? Because the dimensions from the big triangle are always on top. 10 over 5 is 2. 2 equals 6 over y. Cross multiply. 6 times 1 is 6. 2 times y is 2y. Divide both sides by 2. And y is equal to 3. Yeah. Hopefully this is clear. We'll practice it some in class. And I will talk to you later.